Friends, welcome again. Today we are going to start new lesson from the General Science Standard 7. Name of the lesson is that measurement of physical quantities. Okay, in these lessons the major outline points are physical quantities, in which physical quantities, magnitude of physical quantities, scalar quantities, vector quantities, mass, weight, standard measurements, prevailing system of measurements, fundamental quantities, and then international system of units, standards of fundamental quantities, history of a measurement, importance of accurate measurement, major causes of error in measurements, standardizations, and responsibility of the government. These are major outline points of these lessons. Okay, then we clear one by one. Okay, first of all, everywhere when we do all general activities in the market, that means we are purchasing some things like a food, vegetables, fruit grains, then any other things like clothes, pens, books, etc., etc. At that time we use measurement for measuring our objects. Okay, that means physical quantities are such quantities as mass, weight, distance, then temperature, volume, etc. Example: weight of fruits, vegetables, fruit grains, temperature of the body or temperature of some liquids, volume of liquids, density of solid, liquid and gaseous substances, the speed of vehicle, etc. are measured by their physical quantities. That means we measure all these with the help of their physical quantities. Then magnitude of the physical quantities. To express the magnitude of the physical quantities, a value and units are used. Value and units are used. Example: for measuring of the meter and kilometer, the units are used. Which are units? For measuring distance, meter and kilometers are used. Suppose the distance between two cities is 120 kilometers. Then the value and then 120 is the value and kilometer is the unit of the distance. That means magnitude of the physical quantities are units and what we use, value and units. Which is value? Distance between two cities, 120 kilometers. That means 120 is a value and kilometer is the unit for measuring the distance. Different physical quantities are measured by different units. Okay, then scalar quantity. A scalar quantity is completely expressed by the magnitude alone. Scalar quantity is expressed by its magnitude alone. Example: to express quantity such as length, breadth, area, mass, temperature, density, time, work, etc., value with this unit is used. That means value and units both are used with this. Without length we cannot. Suppose length is a unit for measuring the distance, whatever may be. Suppose we are saying give me 10 meter cloth to the shopkeeper. Give me 10 meter cloth. 10 is a unit and 10 is a value and meter is a unit of the measuring of a cloth. Okay, so length, breadth, area, mass, temperature, density, time, work, etc. These are quantities, these are scalar quantities with value and unit used. Example: length of road, 2 kilometers. Temperature of the sick person is 101 Fahrenheit or 100 degree centigrade temperature, etc., etc. Okay. Then next point, vector quantity. The scalar quantity is expressed completely with magnitude and direction. Example, displacement, velocity. Displacement of 20 kilometers towards the north. The aeroplane flying at the velocity 500 kilometers per hour towards the Mumbai. That means we can clear vector quantity and scalar quantity. What is vector quantity? Vector quantity expressed with both magnitude and direction, and scalar quantity expressed by its magnitude alone, not a direction. Okay. Then next point is that mass, the amount of matter present in a substance, is called a mass. Matter has inertia, which is a natural tendency to resist a change in its states. Mass is a qualitative measure of the inertia of an object. This means that if the mass is larger, then inertia is greater. Mass is a scalar quantity. Unit of a mass are gram and kilogram. Okay. I clear this concept. Mass means what? Mass, amount of matter present in the substance, that is called a mass. Matter has inertia, which is a natural tendency to resist the change of the state. That means mass is a scalar quantity and unit of the mass is gram, kilogram, etc. Okay. The next point is that weight. Weight is a gravitational force that acts on the mass. That means the weight of the object is actually the gravitational force by which Earth attracts object towards its center. Weight is a vector quantity. Weight differs at different places on the Earth. The unit of a weight in SI system is Newton. Okay. Then we clear that weight and mass both are different quantities. Weight means matter, amount of matter present in that substance, that is called a weight, and that is a mass. And weight means the object actually gravitational force. Weight of object is actually gravitational force by which Earth attracts toward its center. That means gravitational force that acts on the mass of object, that is a weight. So weight is different on different places on the Earth. In India weight is different, in China weight is different, in America weight is different, but mass is same all over the world. Okay. Then gravitational force of the moon is lesser as compared to the gravitational force of the Earth. Therefore, weight of the body is less on the moon. However, mass remains same on the moon as well as on the Earth. That means this point is clear. The gravitational force on the moon is lesser as compared to the gravitational force of the Earth. Gravitational force of the moon is less as compared to the Earth. So weight of the body is less on the moon as compared to the Earth. So mass remains same on the moon as well as on the Earth. Okay, that is the actual difference between weight and mass. Then the next point is that standardized measurement. Standardized measurement. It is not scientifically correct to measure physical quantities without any standard method. Hence, keep uniformity of measurement and standardized measurement methods to have follow for accurate and standard measurement. Every physical quantity is measured in a standard and specific unit. Example, length is always measured in the unit of a meter. Okay? It is not scientifically correct to measure the physical quantities without any standard method. Hence, to keep uniformity of measurement, standardized measurement methods have to be followed. For accurate and standard measurement, every physical quantity is measured in a standard and a specific unit. Example purpose, length is always measured in unit of a meter. Prevailing systems of the measurements. Which are these prevailing measurements? Which are system? MKS system and CGS system. Okay? MKS means mass, kilogram and second. Distance is measured in meter, mass in kilograms and time in seconds according to the MKS system. Meter, kilogram and second. That means distance, mass, the object, that means which is in kilograms, and time in second according to the MKS system. Distance, mass and times are considered as a fundamental quantities in MKS system, which then the question is that which is asked in exam, which are fundamental quantities considered in the MKS system of the measurement? Distance, mass and time. These three physical quantities are considered as a fundamental quantities in the MKS system. Okay, M for meter, K for kilogram and S for second. Second prevailing system of a measurement is CGS system. Distance is measured in centimeters, mass in grams and time in seconds in CGS system. These three quantities, distance, mass and time, are used to measure all other quantities. That means centimeter, gram and second. Okay, that means you clear that MK system and CGS system, mass, kilogram and second, this is MK system, and centimeter, centimeter, gram and second in CGS system. These are basic fundamental quantities. Okay, that means physical quantity mass in MKS it measured in kilogram and CGS it is in gram. Distance in MKS meter and in CGS centimeter. Time in MK system is measured in second and in CGS system is measured in second. Speed, that means distance upon time, meter upon time in MKS and centimeter upon time in CGS. Okay, now the next point of this lesson is fundamental quantities. Which are fundamental quantities? Why it is a fundamental quantities? The quantities for which the standardized units can be decided called as fundamental quantities. That means quantities for which the standardized unit can be decided are called fundamental quantities. Example, distance and time are the quantities for which standard units have been decided. There is a fundamental unit for fundamental quantities. These fundamental units is available to all. There are 7 basic fundamental quantities. Okay. Next point, that is international system of units. Fundamental quantities, that means which are fundamental quantities, why these are fundamental quantities. The quantities for which standardization units are decided are called the fundamental quantities. For distance and time, quantities for which standardization unit is decided. There is a fundamental unit for fundamental quantities. These fundamental units is available to all. There are, I told again, that means I repeat it, there are 7 basic fundamental quantities. Okay. Then international system of units. Metric system is an international system of units that is based on 7 fundamental units. These are also called system international, that is SI system. The metric system in an international level or international system of units means whenever we go all around the earth, there is some standardization for the measurement, so that metric system, which is used as an international system, that is based on the 7 fundamental units. Okay, this is also called as system international or SI system. It is currently used all over scientific and technological world. SI system is used currently all over scientific level and technological world. The units of fundamental quantities such as length, mass, time in the meter system. That means length in meter, mass in kilogram, and time in second. Okay, symbolically, meter is denoted by small m, kilogram is denoted by small kg, and second is determined or measured by the symbol small s. Standards for the fundamental quantities. What is the standard? At the International Bureau of Weights and Measures at Paris, the standard mass a solid cylinder is made of a platinum iridium alloy is kept. The mass of this cylinder is 1 kilogram as per international agreement. At the same place, platinum iridium bar is kept. It has 2 fine lines engraved on it. Officially accurate copies of these prototypes are kept in the standardizing laboratories institute all over the world. The time required for one revolution of the earth is taken as 24 hours. It is measured by the accurate device. This is considered to be 1 day. 1 hour is considered to have 60 minutes, and 1 minute have 260 seconds. From this, 1 second is standardized. Okay, then next point, that is history of a measurement. In ancient times, for measuring things, man started using part of his own body. Ancient Egypt, to measure distance, cubit was considered. Cubit is a distance from man's elbow to tip of the middle finger. That means from this to this tip. What is this? The unit is cubit. Man's elbow to the tip of the middle finger. This distance man vary from person to person. This is a vary. One person's hand is short, one person's hand is long. So this is vary. Therefore, measurement of king's cubit was considered as a standard. In India, in olden times, gold was measured in unit called as goons. Goons is actually a seed of a tree. For measuring time, an hour, glass was used in olden days. Okay, this is a history of the measurement. Now, importance of accurate measurement. The accuracy of the measurement depends upon its purpose. Thus, appropriate device is chosen for the measurement. Example, precious things, articles of a great importance, and those that are needed to very small quantities have to be measured meticulously and accurately. Advancement in technology have discovered many devices that measure very small magnitude of the quantities like a distance, mass, time and temperature. Example, distance and time in connection with very important sports competition like Olympics. Also, weighting of a mass of a gold, weight of the body, temperature, etc. Major causes of error in measurement. that major causes of errors in measurement. Errors occur if the appropriate device is not used. If appropriate device is not used, then error is occur. Also, if the device is not used properly, errors do not occur in measurement. These are major two fundamental. Errors occur if appropriate device is not used. Also, if the device is not used properly, errors do occur in the measurement. Standardization. It is necessary to standardize the weights and measures used in the markets. Therefore, standard measures are checked from time to time by the government department, which is you are making standardization units are used everywhere. That means in shops, that means in cloth stores, everywhere where measurement is used compulsory. That means for food grains, etc., etc. Okay, it is necessary to standard weights. Okay, if suppose we are going to the shop and purchase 5 kg sugar, if there is somewhat mistakes or somewhat error in the weight, then we are get lost by taking 5 kilo sugars. Okay, it may be 4 kg 500 gram, 4 kg 350 grams, whatever may be. So making 5 kg standard weight, which is checked by the government department time to time. Then a responsibility of the government. What is the responsibility? Weights and measures subdivision functions as a part of food, urban supply and consumer protection division of the government for the prevention of cheating practices. The officers of the subdivision visit different places from time to time for a certain accuracy and efficiency of weight and balances. It is a binding by law to use standard weights and measures for protection, sales and repairs of weights and measures. The weights and measures subdivision grants licenses. The standards of the 6 fundamental units were meter, kilogram, second, Kelvin, ampere, candela are kept in the National Physical Laboratory at New Delhi. Okay, 1 TMC means 1000 million cubic feet. Where is used? TMC word is used at the dam, at the time of water releasing from the dam. What is the capacity of the dam? 10 TMC, 20 TMC, 100 TMC, that is the measurement used in the dam for the storage of the water. That means 1 TMC, tetrametric cube. 1 TMC means 1000 million cubic feet. 1 cubic feet means 28.317 liters. And 1 TMC, that means how many liters? Approximately 28 crore 31 lakh 28 abj 31 crore 68 lakh 46,592 liter. That is a 1 TMC. That is about 28.370 thousand millions liter. That means 28 abj, approximately 28 abj, that is 1 TMC. Okay, here the points regarding with these lessons are completed. Okay, you have any problem, please contact me. Okay.